Hello. If you are seeing this, then let me start off by saying I am deeply apologetic towards your decision to enroll in one of Mr. Taylor's classes. As the end of the year draws near, it may seem impossible to raise your grade above an 84.57%. But with this guide, we can make sure that you will only be up to 2 a.m. studying the night before, and you will be refreshed and prepared for the dreaded Mr. Taylor special, as you will have already studied one section of chemistry. Thermo Chemistry. Enthalpy, represented by a capital H, is the measure of heat within a system. Do not mistake this for temperature, which is the intensity of heat in a system on a comparative scale. We measure enthalpy in joules, and we can calculate the change in enthalpy in a system using the equation Q equal to mc delta T, or QSMAT. Let's use this lad to represent QSMAT.
Water, please.
The three things required to calculate the change in enthalpy in a system are the mass, represented by M, the change in temperature, the delta T, and the specific heat, represented by C. Specific heat is the energy required to change the mass of 1 gram of an object by 1 degree of a temperature, either Kelvin or Celsius.
Please, water.
Let's say we want to figure out the change in energy after we give this lad water to drink.
Thank you.
Let's say the mass of the water he just drank was about 127 grams. This body heat would cause the temperature of the water to go up.
That means that delta T is always positive.
Precisely. And let's say that delta T was about 12.5 degrees Celsius.
That means that the specific heat of water is always 4.8 joules per gram degrees Celsius. Which if you plug that into a QSMAT equation, you'll get an enthalpy change of 6,600 joules.
Precisely. And that is how you use QSMAT.
Hello? Where are you going? Are you going to get help? Hello?
The next thing you'll need to know for the Mr. Taylor final is entropy, or the measure of randomness within a system. One of Mr. Taylor's favorite ways to explain entropy is using his leaves on the ground example. However, as it's spring, there aren't many leaves in the ground. So, we'll be using Mr. Taylor's favorite candy, sour gummy worms, to explain it instead. Right now, the gummy worms are all confined to one system and they are relatively ordered.
However, if we were to dump out the bag of gummy worms, they would be less ordered and therefore have a greater entropy. One way to calculate entropy is by using Hess's law. You would take all the sub-reactions that make up the main reaction and cancel out any species that did not appear in the final products or reactants by multiplication or reversing the reaction. Then you would do the same to each of the sub-reactions entropies, and then finally you would add all the sub-reaction entropies up together to get your final reaction entropy. Gibbs free energy, represented by a capital G, determines the total amount of energy change within a system, measured in joules or kilojoules. Delta G can also tell you whether a reaction is spontaneous or not. If Gibbs free energy is positive, then the reaction is non-spontaneous. If it is negative, then it is spontaneous. Using the values we just talked about, enthalpy and entropy, we can calculate Gibbs free energy using the equation delta G is equal to delta H minus T delta S.
Sup, brother? Got me, dude. I'm making a cool chain, man.
Let us use this equation to determine whether or not the cellular respiration within this hippie is keeping her alive or not. For the value of entropy, use 1.49 kilojoules per Kelvin. For enthalpy, use negative 2,804.8 kilojoules. And for the temperature, use 0.687 Kelvin. Your answer should come out to be negative 2,870 kilojoules.
Does that mean the reaction is spontaneous?
Precisely.
Isn't it so cool how all free energy is spontaneous?
No, that's not what Okay.
Wait, where did you come from? No, wait, where'd you go? Aw, man, that guy's like Cotton Eye Joe. Sweet.
We have now reviewed everything that there is to know about thermochemistry. We covered the concepts of enthalpy and heat, entropy and randomness, and Gibbs free energy and spontaneity. You are now one step closer to surviving the end of the year with Mr. Taylor and possibly raising your grade above an 84.58%.
If you have any questions, comments, or concerns, please email us at whydoyouhavetogiveusafinal@nochemistry.com.
Or you can visit our website, www.istilldontknowhowtitrationworks.ie.
Thank you all for watching, and good luck.
Ready?
Break!